You're going to solve a quadratic using the completing the square method. There's a couple of things you want. You really want your a value, the number in front of your x squared, to be 1. It doesn't have to be. I will probably do an example in class where a isn't 1, but it helps for a is 1. We have another method down here when a is not 1, but if a is 1, that's going to make completing the square have one less step. The b really needs to be even, an even number. So for example, this 6, the term with the x term needs to be an even number. And if you have more than one x term, you need to combine them together before you decide. So if your a is 1 and your b term is an even number, then this is a problem that should be able to be done with completing the square, and it won't have too many problems. Just be ready to rationalize the denominator, because that is often a step that's involved. So it says create a place for the perfect square. So the place that we want is going to be, we're going to want our equation to be x squared plus 6x. And then we're going to have a plus sign, and then we're going to have a space. Okay, we want a space right there because this is where the perfect square is going to go. So how are we going to create a space when right now they're here's the space that I'm talking about. Right now we have a 14 where we want a blank space. So what do we need to do to make that 14 go away? Yes, we're going to subtract 14 from both sides. So I'm just going to subtract 14 from both sides. That's going to give me a 0. That goes right here. I don't really want to put the 0. I just want it to be a blank. But over here, I'm going to get, I believe, -10. Okay, so I've done step number 1. I've created the place for the perfect square. Now, before I go and do this, add the perfect square to both sides, I want to remind you what perfect squares look like. So I have a whole bunch of perfect squares over here. And also I want to talk to you about where it says rewrite it in its factored form. So let's revisit some perfect squares. These are perfect squares because there's three conditions. The leading term is a perfect square, and the root of that first term right there, x squared, is x. Because this symbol right here is a minus, I'm going to put a minus sign right here. And if this is a perfect square, when I put the root of this term right here, when I put that right there, I'm going to do a second check to make sure that these really are equal, to make sure that this equal sign really does go here. And here's my check. Multiply this root times this root and then double it. What's x times 2? 2x. Double 2x. 2x doubled is 4x. That's what I have right here. So that means this is the factored form of that perfect square. Okay, so notice the same thing right here. I'm going to find out if this is a perfect square or not I'm going to go ahead and put the equal sign, assuming that it is, and then if for some reason it doesn't work, I can just put a line through that says it's not equal. So I'm going to go ahead and start the way I always do. What's the root of the squared term? Well, that's x. There's a minus 22 right there, so I'm going to put a minus right there. What's the root of 121? The root of 121 is 11. What's x times 11? Multiply these two roots together. X times 11 is 11x. Double it. 11x doubled is 22, which is that number right there. That means this is a perfect square, and the factored form of that perfect square is x minus 11 squared. So I'm just going to do several of these to show you how easy it is. X squared plus 6x plus 9. The root of x, there's a plus sign in front of the 6, so there'll be a plus sign right there. The root of 9 is 3. Check to make sure the middle term is correct. 3 times x is 3x doubled. That gives me 6x. So the factored form is x plus 3 squared. And this one's going to be x minus 5 squared. This one's going to be x plus 5 squared. This one's going to be x plus 1 squared. This one's going to be x plus 4 squared. I'm putting the root of the squared term in the front. I'm putting the root of the constant in the back, and then I'm making sure that the two roots multiplied together, and then I double it, it gives me that middle term. Okay, so that's having a perfect square trinomial, and this is the factoring part. Now what we have over here is an incomplete perfect square. We've got the middle term right here, but I need a perfect square to go right there, and that perfect square can always be found by taking half of this b term. So I'm going to take half of 6. Half of 6 is 3, and then square the 3. So that means I'm going to put 9 right there, but I'm also going to have to add 9 over here. Now again, remember, I got this 9 right here. This 9 came from half of 6 squared. Half of 6 is 3, and 3 squared gave me 9. That's where that 9 came from. So I took this number right here, took half of it. Now I'm going to write it in factored form. Its factored form is x plus, since this is a plus, this is a plus, and then half of that 6 was 3. Okay. And now it says rewrite it in factored form and combine like terms. You see where it says combine like terms? So I'm going to combine those two terms. So a negative 10 and a positive 9, that's a positive 1. What does it say to do? Take the square root of both sides. Okay, so I'm kind of where I was on the previous set of notes. I'm ready to take the square root of both sides. The x squared is isolated. But that 3 is inside the parentheses, so I can't get rid of the 3 until I get rid of the x squared. So I am ready to take the square root of both sides. I'm going to take the square root of that. I'm going to take the square root of that. And I'm going to be left with x plus 3 equals plus or minus 1. Okay, then it says isolate the x. Because I had that plus 3 in there, I still have the plus 3 there. The square root and the square canceled each other out, but I'm still left with x plus 3. So I got to subtract 3 from both sides. And I end up with negative 3 plus 1 and negative 3 minus 1. Why do I have to do it that way? Because I can. I can put that negative 3 with both a positive 1 and a negative 1. So my two answers are x equals negative 2 and x equals negative 4. Okay. Sometimes you'll end up with a square root in this problem, and I will be sure and do an example in class when you have a square root in the answer. But in this problem, we got a real and a rational answer, negative 2 and negative 4, but imaginary solutions and fraction solutions are possible.